Hi, everybody. So this is Areas Day 3. What more can there be said? Well, I think it's just practice time now. There are a couple of problems I wanted to look at with you that were kind of mistake issues for people, and maybe we could do some calculator stuff. But also I wanted to look at some AP for response questions to see how these area questions show up there. Okay, so I've been given two functions here. One of them is y equals negative x squared plus x plus 2. The other one is y equals negative x to the third plus 4x squared minus x minus 6. All right, so so here's our polynomials, both with negative leading coefficients. But does it look like this? I don't really know. I could set them equal to each other and look for points of intersection and see if that sort of helped me to graph them and figure them out. Yeah, I'm just not seeing the factoring. And I think, in that case, I'm sort of left with, okay, well, then I guess I have to set them equal to each other and find points of intersection. Plus 4x squared minus x minus 6 equals negative x squared plus x plus 2. And it may well turn out that I should have left myself a note here saying, ooh, do this with a calculator. Don't try it by hand. But I'm going to try it by hand and see what happens. So I'm going to get 0 equals x to the third minus 5x squared plus 2x plus 8. Well, that doesn't factor by grouping. And what we're saying these days is we're not going to use Pascal's rational roots theorem. So instead, I've typed the parabola into y1 and the cubic into y2. I'm going to do graph. And I see points of intersection. It looks like there's one at -1 and +2. +2 is definitely 1. How about -1? Yeah, -1 works. And did I see any others? Well, there appears to be one down here. 1, 2, 3, 4. Let's check out 4 also. Oh, 4. No, it's not at 4. Because they both have a value of negative. Oh, they both have the same value. That is a point of intersection. So I've got 3 points of intersection here. I've got the one at -1, and the one at +2, and the one at +4. And the down-pointing parabola is going like that. And the negative cube root, negative cube root is going like that. So here's 4, -10. And this is 2, 0. And -1, 0. Okay, this one is, in fact, let's change their names to make it a little easier on our brains. This is F, and this is G. And so certainly I want to do top minus bottom from -1 to 2. But I don't want to do top minus bottom from -1 to 4. It's true that F is the top function on this interval from -1 to 2, but that's not true over here. It's G that's on top here, and F on the bottom here. And so I'm going to expect to see something along the lines of the total area is the integral of f of x minus g of x from -1 to 2 plus the integral from 2 to 4 of g of x minus f of x dx. Okay, so here's the thing. Yes, you can use this if you define these functions or if they've already been defined. However, you can't stop here unless the problem says simply, please set up but don't evaluate. Well, yeah, that doesn't happen enough. In fact, more often we're told to, find the total area. So we know then that we would have the integral from -1 to 2 of negative x squared plus x plus 2 minus. Now remember, when we subtract g of x, it's not just this part that's getting subtracted. It's all of these terms. So that negative has to go to all of those terms. And then I'm going to combine like terms, and then I'm going to do the antiderivative, and then I'm going to plug these values in. That's a bunch of work. And that's only for the first part. I still need to do the second part, plus the integral from 2 to 4. This time g of x comes first. Minus the parabola, negative x squared plus x plus 2 dx. And again, this has to be distributed. And the number one mistake on these problems is not students forgetting about top minus bottom. The number one mistake is forgetting to distribute that negative throughout. So please watch out for that. I would say the second most common mistake is students only see one region instead of two for whatever reason. Like they don't look enough. They see a region and they stop. Maybe their calculator was only set like this, and so they just saw this region. Yeah, and they don't see that there's going to be another region over here. But surely this is going to come down, and this is going to come down, and they're going to intersect. So I've got another one. So be on the watch for that as well. Okay. You'll need to finish this, but I'm not going to finish it because you don't really need to see me go through it. But let's take a look at this together. F of x equals 3 minus x squared, and g of x equals, that's remarkably similar. Yeah, okay. Because what I want to do is I really want to use the calculator for this. Make sure you're comfortable with that. This is certainly a reasonable with calculator problem. Well, we graphed this one already. We've seen this one. Something like that going on. And now I've got my negative x squared plus 3 to look at. And so again, is it going like this? Is it going like this? I don't know. So while I could graph this, yeah, no. So let's take a look. We're going to have negative x squared plus 3. And graph. It looks a lot like the last one. I need to go a little more to the left, and I need to go a little more down. So I'm going to change my viewing window. How about negative 3? And how about going down to negative 20 and steps of 2? Okay. All right. So, yeah, I've got the parabola on top and the cubic on the bottom. And here I have the cubic on top and the parabola on the bottom. Don't forget, when you do these integrals, it's not the x-intercept of the function we're looking for. It's the point of intersection on the graphs. So second, calculate, intersect. And I'm going to bring it closer to this point of intersection. Enter, enter, enter. And I get a value here of negative 1.132637. And where am I going to? Well, I'm going until I get to that point. So second, calculate, intersect. All enter, enter, enter. And that gives me 1.8595646. Excellent. And that's going to be f minus g. But we want to add to that this other integral, which goes from 1.8595646 with g minus f dx. And where's that point of intersection? Over there. Second, calculate, intersect. One, two, three. All right, 4.2730729. Fabulous. So we're going to, since this is with calculator, because I couldn't have found those intersection points any other way, I'm going to do this with the calculator. Oh, by the way, some people may have discovered this thing down here, the integral of f of x. Yeah, I don't actually use that one. It's not as consistently correct as the one here, function integral. So yeah, I know some people like the graphy one. No thanks. Okay, so I'm going to say that f is in y1. Yes. So I want math, function integral, and we've got y1 minus, and I put mine in y4, I believe, comma x, comma this one, negative 1.132637, comma 1.8595646. Okay, there's my first integral. That comes back with a value of 17.4564. And what about this second integral? So for the second integral, we're still oh no, we're not. We're going to do y4 this time minus y1. And we want to go from 1.859, good, until we get to this other point, comma 4.2730729. And that one is 9.83867. So if we add these together, we have 17.4568482. And I get, remember to round to three places, 27.295. All right, there's our total area. Sometimes you'll need your calculator. All right, so next, what about this situation? I've got, what do I have? Do I have that? It seems curiously absent. Okay, so what if my functions are square root of x and 2 minus x? Okay, so let's think about this situation. We've got square root of x, and that's f, and what about g? G is this function, and I see a couple of regions here, region 1, region 2. All right, so let's start with figuring out the area in region 1. So, okay. Now, we've been saying a lot in the last couple of videos, and hopefully as well in class, that top minus bottom is great, except there's a problem with top minus bottom here. What is it? What's the issue with trying to do top minus bottom here? So I agree that we have one bottom. But from 0 to 1, the square root is my top function. And from 1 to 2, this linear 2 minus x is my function, is my top. So I have two different tops. So I'm going to set this up, or I'm going to have to set this up as the integral from 0 to 1. How do I know that's 1? Well, I could set this equal to that, and then square both sides. Subtract that x. 0 equals x squared minus 5x plus 4, which is x minus 1 and x minus 4. And lo and behold, these things intersect at 1. Yeah, remember, this is a must-check situation because we squared both sides, and it turns out that 4 doesn't work. 4 would work if we had the plus or minus, but we don't have the plus or minus, and so we're not going to have to worry about that. This is just the point 1, 1. So I'm integrating from 0 to 1, square root of x dx. And then I want to add to that the integral from 1 to 2 of 2 minus x dx. And that's pretty easy and straightforward, but it's definitely requiring two separate integrals over two separate intervals from me. Okay? So what would we have here? Well, this is going to be x to the 3 halves with the 2/3 in front from 0 to 1. Plus here we're going to have a 2x minus x squared over 2 from 1 to 2. Okay, so if I plug a 1 in there, I get 2/3. If I plug a 0 in there, I get 0. That's a minus. And now we're adding this other integral. If I plug a 2 in here, I'm going to have 4 minus 2 squared is 4 over 2 is 2. So 4 minus 2 is 2. And if I plug a 1 in here, that's going to be 2 minus 1 half, which is minus 3 halves. So what do I get? Well, I believe I get 2/3 plus 1 half. And it looks like 7/6. I think that area is 7/6, and that's pretty straightforward and reasonable. However, you also could set this up. Instead of using top minus bottom with two integrals, we could do right minus left. Okay, and the thing about right minus left is the right thing is always the right thing, and the left thing, it's always the left thing. So you only need one integral here. But instead of going this way, like my last problem did, I'm going to be going this way when I do right minus left. So I'm going to have the integral of g minus f. But look at these slices. These slices are things measured on the y-axis. So this needs to be a dy. So I don't want to have these things in y as a function of x. I need x as a function of y. So y equals square root of x. So x equals y squared. Okay. So the left function is y squared. And what about this one? Y equals 2 minus x is the same as x minus y. I'm sorry, 2 minus y. And so this one is always my right function, g. So this integral is going to be 2 minus y squared dy. And we're integrating from 0 to what y value? Ooh, the y value of 1. So 0 to 1. Excellent. So when I integrate here, I get 2y minus y squared over 2 minus y to the third over 3. I'm going from 0 to 1. When I plug a 0 in there, I just get a big old 0. And when I plug a 1 in there, I'm getting 2 minus a half minus a third. All right, so that's 12/6 minus 3/6 minus 2/6. 12 minus 5 is 7/6. See, I could do it either way. I will say that a more complicated top minus bottom is always going to be an easier right minus left. All right, so that was finding region 1. Will you please find region 2? Please find region 2. Ooh, I kind of want to say find it 3 different ways. Okay, see if you can find 3 different ways to find region 2. All right, what did you discover? What did you see? I think the first method is top minus bottom, because this is one top the whole way and one bottom the whole way. So probably my preferred, and these slices go this way. So top minus bottom is going to be the integral of 2 minus x minus square root of x dx. And we're integrating from the x value here of 0 to the x value here of 1. 0 to 1. So there's one method. A second method would be to do a hard right minus left. And why do I say hard? Well, because I have to split into 2 integrals. Right minus left. The integral of 2 minus y dy from 1 to 2. Plus, what about down here? Well, look, my right curve is different this time. The right curve here is y squared. Ooh. And the left curve is 0. Okay, so y squared minus 0 dy. I guess I should put that minus 0 here as well. This is right minus left. And here I'm integrating from 0 to this y value, 0 to 1. This should generate the same answer as this. And I wanted a third method. I guess my third method would be to take the area of the big triangle, which is 1/2 2 times 2, and subtract region 1. And we already found that area to be 7/6. So 12/6 minus 7/6 should be 5/6. So when I do these other 2 approaches, I should also be able to get 5/6. Generally speaking, College Board does not say do it this way. They just say find an area. Okay? Okay. So let's move on to these free response questions. I'm taking a look at this partner problems worksheet. 2012 with calculator. Let R be region in the first quadrant bounded by the graphs of y equals ln of x and y equals 5 minus x. Okay, so what does that look like? Well, I think that looks like this. Here's 5 minus x, and here's ln of x. And we're looking for, this is 1, this is 5. We're looking for this area here. Okay, so again, we could split this up into 2 integrals. And in fact, that's generally speaking what College Board expects. See, I don't know where they intersect though. When I set one function equal to the other one, yeah, I don't know how to get the x's alone on one side. This is definitely a graphing calculator question. It seems so straightforward, but in order to find that point, I'm going to have to do some graphing. So I'm going to graph the ln of x. And down here, I'm going to graph 5 minus x. And we already know our window goes from 1 to 5. So 0 to 6. And what about our y values? Well, that's 5, and that's less than 5, and I definitely don't need anything in negative land. So I'm going to go 0 to 5 in steps of 1. Graph. Okay. And here, and we integrate. Second, calculate, we intersect. 1, 2, 3. And I get that ordered pair is 3.6934414, comma 1.30655586. Okay, there's our ordered pair. Now, so some students like to do the integral of ln of x from 1 to 3.6934414. And then they add to that the integral from there to 5, 3.6934414 to 5, and this time it's 5 minus x dx. And no, I don't think they're going to say find those antiderivatives and then plug these values in. I think this is going to be something you'll be doing with your calculator. Okay, so that's one answer to what's the area there. But yeah, I think there's a lot to be said about right minus left here. Because again, I only need one integral. This is always the left, and this is always the right. Okay? So, but I do need these in x equals form. So if I exponentiate here, I get x equals e to the y. That's this one. And this one over here, when I add x to both sides and subtract y, I get x equals 5 minus y. And this one is always 5 minus y. So my integral, which goes from here to here, those are y values. So I want this, 1.3065586. And I'm going from 0, my right function, 5 minus y, minus my left, e to the y dy. Okay, so as one integral or as two, either way, should get the same values. Please notice, though, that on our dx integral, we've got x values. On our dy integral, that's a y value. I'm integrating from here to here, that y value. As opposed to here, I'm integrating from 1 to here with x values. And from here to 5, those are x values. Pay attention to those, please. Okay, so that's part A. Find that area. Good. I'm sure you can do that computation on your calculator. The next question says, the horizontal line divides R into two regions of equal area. So there's a line here, y equals k. Because it's y equals k, we know it's a horizontal line, not a vertical line. So there's a horizontal line somewhere, such that when I draw that horizontal line, the area above that line and the area below that line are equal to each other. And they say here, write, but do not solve, an equation involving one or more integrals whose solution gives the value of k. All right, well, so there are a bunch of different ways that I've seen students do problems like this. So, for example, this is my area for R. Well, I could take this area and say, well, I want half of that. I want half of that. But then, I've got to figure out, like, if I'm doing this, how do I know where to integrate from and to? Got no idea with those. I mean, geez. That's y equals k, but I guess the only way for me to find the x value here would be to put that value in. And so I'd have to say that half of the area is equal to the integral from y equals k. So I've got to the k to 3.693 of ln of x dx plus, from that same 3.693 place to here, which is 5 minus k of 5 minus x dx. I just don't like that. Like, this has to equal this. Oh, that's just an abomination. Just horrible. Okay. What's another way? Well, if we do right minus left, I'm integrating from this y value to this y value. And this is my y equals k. So maybe k to 1.30, 65506, and I'm integrating from here to here. Yes, these are dy's, and I want 5 minus y minus e to the y. Yeah, I think that's a lot easier, and that's supposed to equal half of this area that I already found by one of these methods. 1/2 of one of those things. And you could certainly, you're going to have found the number for part A. You can just shove that number in here divided by 2. Yeah, I think that would be easy. Okay, I believe the area was 2.986, and so I want 1/2 times 2.986 equals that integral. All right. No, remember, they're not asking me to solve. They just want me to set up something. Set up something that finds that area. Okay, here's this next problem. It's from 2013. This one's without calculator, though. 2013 without calculator. We're given the function f as 2x squared minus 6x plus 4. And we're given g for cosine pi over 4x. And they give us a little picture. It was nice of them. And this one comes like that. And there's this other one that goes like that. And so we get a point of intersection here at 2, 0. And another point of intersection here at 0, 4. Now, curiously, I'm not quite sure which is which, but wait a second. This is a positive x squared. That can't be this. So this has to be g, and this has to be f. Okay, and what did they ask us to do? Find the area of R. They want us to find the area of this region. Well, that's easy enough to do. Part A, we're just going to have the integral from top 4 cosine pi over 4x minus bottom 2x squared minus 6x plus 4 dx. And I'm integrating from here to here. So this is a dx integral. I'm using x bounds on my integral. Okay, now notice how this thing was no calculator. So we need to be able to, find the antiderivative of this without that need. So whose derivative is cosine? Cosine's derivative, this is the derivative of sine. So for sine, now be sure about this. And you may want to use a u sub to figure out this integral. In fact, I may want to use a u sub over 4x. So du is pi over 4 dx. Okay, so 4 over pi du is dx. So I can get rid of the dx here by saying 4 over pi. So it's the integral 4 cosine u times 4 over pi. right? So I'm going to have 16 over pi sine pi over 4x. And we're evaluating that from 0 to 2. Well, we know the sine of 0 is 0. If I plug a 2 in here, the sine of pi over 2 is 1. And so I get this area as 1 times 16 over pi. Well, this is going to be 16 over pi. Okay, now what about over here? Well, again, this, or if you're not going to distribute, find the value of that integral from 0 to 2, 2x squared minus 6x plus 4 dx, and put a minus in front of it. So that's going to be 2x to the third over 3 minus 3x squared plus 4x, and we're going from 0 to 2. Now when I plug in a 0, I get a whole bunch of those zeros. If I plug in a 2, I have 8 times 2 is 16. 16 thirds. 2 squared is 4. 4 times 2 is 12. And plus 4 times 2 is 8. All right. So 16 thirds minus 36 thirds is negative 20 thirds plus 24 thirds is going to be 4 thirds. So I'm subtracting 4 thirds from that 16 over pi answer that I got before. All right, and that's fine. It's a beautiful answer. We're good with that. Yeah, nice, straightforward problem. No scary there. Is there a part B? There's no part B. That's it. Just that. I think the hardest part for people is to remember to keep breathing when they see a polynomial and a trig function together. Wasn't a problem here. No, I would not do right minus left, because I have this right function from 0 to 4. But then I have this right thing. And 1, I don't know that y value. And 2, right minus left is the same curve. And so that would be really hard. Okay. Third problem here. This is from 2014. This says also with calculator. We've got f of x equals x to the fourth minus 2.3x to the third plus 4. Ooh, and the horizontal line y equals 4. Okay, so that graph kind of looks something like this. And that. And that. This is the line y equals 4. This is f of x. And the first thing they say, or at least the first thing I've got here that they say, is the vertical line x equals k divides r into 2 x equals k. Two regions that are equal. This area equals that area. Right, but do not solve an equation involving an integral expression or expressions whose solutions give a value of k. Well, okay, so let's think about this. I think I need to know where that point of intersection is. Do I need to know where that is? And that's where 4 equals this quartic polynomial. So let's type in that quartic polynomial. X to the fourth minus 2.3 x to the third plus 4. And this other one down here, y equals 4. And I want to know where that point is. So I can calculate, intersect, and my calculator goes to the point of intersection. Which means paying attention to the y values and not going up forever. Hello, little cursor. There you are. No. Silly doofus. Second, calculate, intersect. 3. Okay. So this point turns out to be It's very convenient. 2.3 comma 4. Okay. And this one over here is 0, 0. So, two regions of the area, right, but do not solve an equation involving integral expressions whose solution gives you the value of k. All right, well, so most students say that they want to do here top minus bottom. And that's good because in this situation, right and left, same function. So I kind of, don't want that. So let's do this top minus bottom. We're going from 0 to 4 of 4 top minus bottom dx. That's the whole area. That's the area for R. Okay. Okay. But I want only half of that. So I'm going to say the integral from 0 to k of 4 minus f dx equals 1/2 r. I've defined r to be this number, and so now I have half of that. You could, of course, go 0 to k 4 minus f dx equals 1/2 integral 0 to 4 4 minus f dx. Yeah, I think that works. Yeah. Yeah. I mean, I guess I could do this one instead and say from k to 2.3. That would also generate the correct area. And my guess is that maybe in part A, they asked us to find this area. And now in part B, they want me to find how far over I have to go. Or like in that last problem where they drew the horizontal line, how far up and down do I need to go? Yeah, I'd be thinking about getting comfortable with those last two problems. And it did just say, write but do not solve. So I'm walking away and on to the last problem here on this worksheet. And this one says, let f and g be functions defined in this manner. F equals 1 plus x plus e to the x squared minus 2x. Isn't that interesting? And g equals x to the 4th minus 6.5x squared plus 6x plus 2. All right. Yeah, well, no, please stop worrying. Of course, this is with calculator. I mean, come on now. I know I've made it so you can graph many things, but this will be hard. They give us a picture here. And the picture looks like that. And a point of intersection. And that. All right. So, yeah. Which of these is on top? They don't tell me. They expect me to find out by graphing. And so I determined here when I graphed this and graphed this that this was G and this was F. And then they flip at this point. This is F, this is G. We don't know where that point of intersection is, but you know, that's what we do on the calculator. We're going to graph G, x to the 4th minus 6.5 x squared plus 6x plus 2. And then down here we've got 1 plus x plus e to the x squared minus 2x. All right. And off and graph. I'm going to change my viewing window so that I get a little more space, as it were, to see what's going on here. And I need to find that point of intersection. So I can calculate, intersect, and we get the point. This point is 1.0328319, comma 2.4011081. All right. So I guess I would do one integral with g minus f from 0 to 1.0328319 of g minus f. And I can do that because they've defined g and f for me. And I want to add to that the integral where f is on top and g is on the bottom. So it's going to be the integral from 1.0328319 up to this x value here at 4, and that's going to be f minus g dx. I'll do it in my calculator so that you can have a value for that. Okay, we've got math, function integral. I want y1 minus variables. I'll put this one in y3, comma x, comma 0, comma 1.0328319 plus the integral of y3 minus y1, comma x, comma 1.0328319, comma 4. Okay. And it thinks, and it thinks, and it thinks, and I'm really appreciative. Got a lot of gratitude because I certainly don't want to do that. And I seem to come up with a number that's remarkably different than what I had written down. Oh, because that's the point 2, not the point 4. Okay, 2. And yes, integrate. There we go, 2.004. All right, well, I hope things go well for you with this. This is the last of the content before our test, and I hope you all do comfortably well on the test. All right, take care, everyone.